Now, batteries can't replace diesel, but new technologies with ammonia are emerging, and big money is pouring into the startups at the helm.
In a groundbreaking announcement that could redefine the future of transportation and energy, Elon Musk has unveiled a revolutionary new water engine. This astonishing innovation promises to change everything we know about how engines work, potentially setting the stage for an era of unprecedented environmental sustainability. But what makes this water engine so different? And how could it potentially alter the landscape of global technology and ecology? Let's uncover the mechanics behind Musk's latest venture and explore its far-reaching implications. Elon Musk surprised his X, formerly known as Twitter followers, by revealing a significant change in Tesla's direction. After years of skepticism, Musk announced that in 2024, Tesla will make a switch from batteries to hydrogen power. This unexpected shift was further emphasized as he disclosed that the first vehicle utilizing this new fuel source will be named the Model H. Musk had once referred to hydrogen fuel cells as fool cells and expressed his belief that the technology was mind-bogglingly stupid. This complete reversal is now credited to challenges encountered in the mass production of the 4680 battery, prompting the company to reconsider its approach and opt for hydrogen power as an alternative solution. Tesla, the global leader in electric vehicles since its establishment in 2003, has been spearheaded by Elon Musk. Committed to enhancing the average living standards through cutting-edge technology while prioritizing environmental sustainability, Musk has steered Tesla to the forefront of the renewable energy and transportation revolution. Investing in various eco-friendly projects and utilizing his platforms to advocate for change, Musk aims to change the way people think about energy, fuel, and climate change. As the world increasingly accepts and advocates for cleaner energy solutions to combat climate change, electric vehicles, with Tesla leading the charge, are gaining popularity. Tesla has recently gone public with their plan to introduce a new energy source: hydrogen fuel cells. This development prompts the question: what are hydrogen fuel cells, and how will they transform your driving experience? Vehicles, notorious for contributing significantly to climate change through fuel combustion, have seen a transformative alternative in electric cars. Tesla, Musk's multi-billion-dollar automotive giant, produces 500,000 electric vehicles annually, contributing substantially to the growing societal acceptance of electric cars. Electric cars, like those produced by Tesla, primarily rely on batteries for power. These batteries, similar to those in laptops but larger, store electricity obtained from the grid or charging stations. However, issues such as long charging times, range anxiety, and high costs have deterred consumers. In response, hydrogen fuel cells have emerged as a promising alternative, eliminating many of these drawbacks. Contrary to Musk's earlier skepticism about hydrogen technology, fuel cells have gained interest in the automotive industry. But what exactly is a hydrogen fuel cell, and how does it function? Positioned strategically among a vehicle's components, the fuel cell collaborates with a battery, electric engine, and hydrogen tank to generate energy. Multiple fuel cells work simultaneously through a process called reverse electrolysis, where hydrogen reacts with oxygen to produce electrical energy. Unlike traditional electric vehicle batteries, fuel cell batteries are smaller as they are constantly charged by the fuel cell. This process ensures a continuous and sufficient supply of electricity. The byproduct of the fuel cell is water vapor, emitted harmlessly into the air. The quality of hydrogen used influences whether the byproducts contribute to climate change. Renewable energy sources produce hydrogen with a neutral carbon footprint. Despite public perceptions, scientists believe that hydrogen fuel cell technology holds promise and will catch up in the coming years. Apart from the environmental benefits, fuel cell electric vehicles offer distinct advantages in the driving experience. One noticeable difference is the silence of electric vehicles. Without the mechanical sounds associated with traditional cars, electric vehicles provide a remarkably quiet ride. Hydrogen fuel cars, taking this a step further, stand out even among their electric counterparts due to their swift refueling time. Charging time is a significant factor between battery electric and hydrogen fuel cell cars. While battery electric cars may take several hours to charge fully, hydrogen fuel cars are ready to go in no time, provided the hydrogen tanks are filled. This, coupled with the energy output of a hydrogen tank, gives fuel cell cars a more extensive range than their electric counterparts. From 2024 onward, the first vehicle to feature this innovation will be the Model H, boasting technology and a remarkable 0 to 60 miles per hour acceleration in just 1.2 seconds, with a range of 450 kilometers. While hydrogen fuel cars are currently more expensive due to their rarity and the limited availability of hydrogen stations, industry experts predict a change in the next decade. With the urgency to address climate change, more automobile companies are embracing cleaner technologies. Model 2 and Model 0 are slated for release in 2025 and 2027, respectively, and are expected to be supercars. As Tesla pioneers this shift toward hydrogen fuel cells, the automotive landscape is ready for a significant transformation. Elon Musk is no stranger to controversy, and one of his lasting points of contention lies in his strong views on hydrogen as a fuel source for vehicles. However, as with many debates, not everyone is in harmony with Musk's perspective. In the changing landscape of electric vehicles, EVs, there exists a difference of opinions on the potential of hydrogen fuel cells versus traditional batteries. Musk's stance on hydrogen is robust and dates back several years. During a discussion at the Automotive News World Congress, he honestly labeled hydrogen fuel cells as extremely silly. Musk highlighted the inherent challenges of producing, storing, and utilizing hydrogen in automobiles, emphasizing the technological superiority of existing battery technologies. Even with Musk's rigid position, the automotive arena is not a single company. Major players in the industry, including Toyota and Hyundai, have invested substantially in the development and production of hydrogen fuel cell vehicles. This commitment extends beyond industry giants, with smaller manufacturers like Riversimple actively engaged in creating hydrogen-powered cars. The contrast in opinions is not limited to the manufacturing side of the industry. Other prominent figures, such as Herbert Diess, the CEO of Volkswagen Group, have voiced similar concerns about the viability of hydrogen in the automotive sector. Diess states that green hydrogen produced using renewable energy sources is better suited for heavy industries like steel and chemicals, and should not find application in automobiles due to being expensive, inefficient, slow, and logistically challenging. Musk's beliefs on hydrogen, expressed on various occasions, include a series of tweets in mid-2020 where he declared, "Fuel cells = fool cells," and insistently stated that hydrogen fuel cells make no sense. Despite these unequivocal statements, Musk has not publicly indicated any shift in his views on hydrogen when contacted via Tesla by CNBC. The technological foundations of Musk's skepticism toward hydrogen lie in the fundamental differences between traditional battery electric vehicles and those powered by hydrogen fuel cells. According to the U.S. Environmental Protection Agency, EPA, hydrogen fuel cell vehicles, also known as fuel cell electric vehicles, FCEVs, share similarities with electric vehicles in that they use an electric motor instead of an internal combustion engine to propel the vehicle. However, the key distinction lies in how these vehicles generate electricity. In the industry of electric vehicles, batteries necessitate charging through external power sources. Contrastingly, fuel cell vehicles use hydrogen gas to generate electricity on board. This process involves the mixing of hydrogen gas from a tank with oxygen, resulting in the production of electricity. The diversity of opinions within the automotive sector is symbolic of the broader debate surrounding the future of transportation and the role of hydrogen in it. In June, the BMW Group announced the initiation of tests for vehicles featuring a hydrogen fuel cell drivetrain, emphasizing its potential to complement internal combustion engines, plug-in hybrid systems, and battery electric vehicles. Despite the growing interest in hydrogen, especially within the context of fuel cell electric vehicles, it's essential to recognize that these technologies are not yet dominant in the market. Companies like Riversimple, though actively working on hydrogen-powered cars, offer them on a subscription basis, indicating that such vehicles do not currently constitute a substantial portion of overall car sales. Toyota, a large supporter of hydrogen technology, imagines its applications extending beyond automobiles to diverse settings, including heating, lighting, haulage, mass transit, and heavy industry. The Fuel Cell and Hydrogen Energy Association voiced this idea, emphasizing the zero-emission benefits, long-range capabilities, quick refueling, and scalability of fuel cell electric vehicles and hydrogen energy. In the pursuit of low and zero-emission transportation, the conversation extends beyond passenger vehicles. Larger forms of transport, such as trucks, buses, trains, and planes, are increasingly considered within the purview of hydrogen fuel cells. Daimler Truck's CEO, Martin Daum, advocates for a balanced approach, acknowledging the suitability of different technologies for distinct scenarios. While battery electric vehicles excel in city deliveries with lower energy requirements, long-distance transportation scenarios might benefit from the practicality of hydrogen fuel cells. The versatility of hydrogen fuel cells finds expression in various sectors beyond automobiles. European transport giant Alstom has developed the Coradia I-Lint, advertised as the world's first passenger train powered by a hydrogen fuel cell. In aviation, plans to operate commercial hydrogen electric flights have been announced, with aspirations to take to the skies in 2024. The construction industry, represented by major players like JCB, has not been left behind, with the development of a 20-ton excavator powered by a hydrogen fuel cell. While excitement surrounds the potential applications of hydrogen fuel cell technology, the path to mass adoption faces some big challenges. Honda's decision to stop production of its Clarity plug-in hybrid and fuel cell models earlier this year demonstrates the hurdles related to durability, reliability, and vehicle cost. The US government has highlighted infrastructure limitations as a significant obstruction, quoting concerns about the current inability of the infrastructure to support the widespread adoption of fuel cell vehicles. The competitive landscape further complicates hydrogen's trajectory in the transportation sector. Green hydrogen, produced using renewable sources, not only contends with traditional fossil fuel-based hydrogen, but also competes with other conventional fuels such as petrol, diesel, and electricity. The challenges outlined by the International Energy Agency's Global EV Outlook 2021 emphasize the existing gap in registrations between fuel cell electric vehicles and traditional electric vehicles, attaching it to the limited availability of hydrogen refueling stations. Many people on X, formerly Twitter, have come together to discuss how they feel about this new revelation. Some have voiced their concerns that Musk had so strongly rejected these ideas of hydrogen-fueled vehicles for years and is now pushing ahead leading this change. Understandably, due to Musk's contradictions, critics remain skeptical until further information is given. Conversations have also turned to what Musk will capitalize on next. With talks of an ammonia engine, when will people say enough is enough? The answer lies in the unique properties of ammonia, a hydrogen compound with higher energy density compared to hydrogen gas. An ammonia engine could potentially offer greater range than traditional combustion engines without the emissions linked to gasoline or diesel. Ammonia can be produced sustainably from renewable sources, adding a layer of environmental sustainability to the fuel. However, skepticism exists regarding the future dominance of ammonia, with critics arguing that the transition faces challenges, including the virtually non-existent infrastructure for ammonia refueling. Safety concerns, Potential accidents and the energy-intensive production process also cast shadows on ammonia's viability. The success of this venture is not agreed yet, and this engine is in its very early days of discussion and development. In the ongoing race to shape the low and zero-emission future of 21st century transportation, battery electric vehicles currently lead the charge. However, the road to success is not simply a straight line or without obstacles.
Along the way, Neuralink can solve a lot of brain issues. I think the work in Neuralink will definitely shed a lot of insight into how the brain and the mind work.
Elon Musk delves into the future, envisioning a world where the lion's share of human intelligence resides within the digital realm, opening new frontiers and understanding cognition.
And hopefully bring us along for the ride, you know. But the vast majority of our intelligence will be digital. This is think of the difference in intelligence between the cortex and your limbic system is gigantic. Your limbic system really has no comprehension of what the cortex is doing. And in the short term, can interface with any given section of your brain and solve a tremendous number of things that cause debilitating issues for people. So Neuralink, you'll be able to see Neuralink coming from a very long distance, because any device that you implant in a human you have to go through so many tests. It moves very slowly. You just do a few people at a time, and then you go to extreme lengths to prove safety. So I want to emphasize the purpose of Neuralink. What's our goal? Our goal is to solve important spine and brain problems with a seamlessly implanted device. So you want to have a device that you can basically put in your head and feel and look totally normal, but it solves some important problem in your brain or spine.
Exploring the mission of Neuralink, Musk elucidates the groundbreaking pursuit of addressing brain and spinal injuries, ushering in an era where neural maladies are not just treated but revolutionized.
The overarching goal of Neuralink is to create ultimately a whole brain interface. So a generalized input-output device that, in the long term, literally could interface with every aspect of your brain. Well, I mean, the thing I wanted to emphasize is that it's not going to sort of pounce on us overnight. Mm-hmm. You'll see it coming. It's going to be very slow. In fact, I really think that artificial general intelligence or digital superintelligence is likely to arrive before we have really advanced neural links. At least that's where the trend is right now.
Mm-hmm. Musk paints a future where the profound advancements of Neuralink might enable the transfer of human cognitive capacities into an unprecedented realm, akin to a digital Optimus.
Well, yeah, I mean, Neuralink, in the short term, Neuralink is just about solving, brain injuries and spinal injuries and that kind of thing. So to be clear, for many years, Neuralink's products will just be helpful to someone who has lost the use of their arms and legs, or who has just a traumatic brain injury of some kind. That's what Neuralink will be useful for many years.
But in our last conversation, you said that Neuralink is among all your projects, for you, the most important one. Is that still true?
I know I said it could be. I wouldn't say for sure it is the most important, but it could be the most important, in that there is a long-term mitigation to artificial intelligence, which is that we could effectively merge with artificial intelligence by improving the speed of interaction between our cortex and our tertiary layer, which is already silicon. We're already a sort of a 3-level intelligence creature. The base level is the limbic system, the sort of animal brain or reptile brain, essentially, the sort of fundamental, the animal or reptile brain. And then there's the cortex, which the cortex, by the way, is largely in service to the reptile brain.
Could you imagine that one day we would be able to download our human brain capacity into a Optimus?
Yes. I think that is, I'm not saying this is, I think it is possible, to do that. It is possible.
The aspiration to unlock the mysteries of the human mind drives Neuralink's endeavors, promising to unravel the intricacies of the brain's functioning and its profound interplay with the mind.
But ultimately, the idea would be to achieve a symbiosis between our biological mind and our kind of digital mind. So we're already kind of a cyborg if you think of like your phone and your computers as an extension of yourself.
Mm-hmm.
In fact, like if you leave your phone behind, it's like you have missing limb syndrome. You're like, where did it go? So the phone is a kind of an extension of ourselves, like computer is. The various applications that we use are already an extension of self. So we are already a cyborg. It's just that the interface is with our eyes and our fingers.
Yeah.
And that interface, especially output, the rate at which we can type words into a phone or a computer, it's very slow. Our input is much better because with the data rate from vision is, I don't know, many thousands of times, maybe 1 million times better than the rate at which we can output. So input is like maybe, roughly 1 million times better than output.
Describing neurons as the wiring of the brain, Musk underscores the necessity of electronic solutions to address the intricate electronic challenges posed by neural malfunctions.
Yeah, I think the work in Neuralink will definitely shed a lot of insight into how the brain and the mind works. Right now, just the data we have regarding how the brain works is very limited. We've got fMRI, which is that's kind of like putting a stethoscope on the outside of a factory wall and then putting it like all over the factory wall, and you can sort of hear the sounds, but you don't know what the machines are doing really. It's hard. You can infer a few things, but it's very broad brushstroke. In order to really know what's going on in the brain, you have to have high precision sensors, and then you want to have stimulus and response. Like if you trigger a neuron, how do you feel? What do you see? How does it change your perception of the world?
Musk highlights the paradox of the cerebral cortex, showcasing its superior intelligence while acknowledging its predominant role in striving to appease the more primitive limbic system.
And the reality is that almost everyone over time will develop brain and spine problems. These range from minor to very severe, but if you live long enough, everyone's going to basically have some kind of neurological disorder. And these range from memory loss to brain damage. But the thing that's important to appreciate is that an implantable device can actually solve these problems. I think a lot of people don't quite realize that. But all of your senses, your sight, hearing, feeling, pain, these are all electrical signals sent by neurons to your brain. And if you can correct these signals, you can solve everything from memory loss, hearing loss, blindness, paralysis, depression, insomnia, extreme pain, seizures, anxiety, addiction, strokes, brain damage. These can all be solved with an implantable neural link. This is an extremely fundamental thing, and I think a lot of people don't quite understand that. The neurons are like wiring, and you kind of need an electronic thing to solve an electronic problem.
Beyond the confines of conventional safety standards, Musk assures that Neuralink is pushing the boundaries, ensuring a level of safety that exceeds even the stringent requirements of regulatory bodies.
So what a Neuralink device can do is improve that bandwidth, allow you to be sort of much more symbiotic with the AI extension of yourself. So you can think of like a human brain really is could be arguably divided into two parts. One is kind of like the primitive brain, the reptile brain, it's sometimes called. It's like a sort of basic instincts, and then we've got the cortex, like the higher level thinking, planning, and that kind of thing. The two operate symbiotically. So I haven't yet met anyone who wants to delete their limbic system or delete their cortex. Everyone's quite happy having both. Yeah, they're like, oh, I like it the way it is, But your cortex is way smarter than your limbic system. But the irony is that even though the cortex is way smarter than the limbic system, most of what it's doing is trying to make the limbic system happy.
The ultimate objective is to restore functionality to individuals, severed from a full connection between their brain and body, ushering in an era of unprecedented neural restoration.
A lot of times people think that they couldn't really work at Neuralink because they don't know anything about biology or how brains work. And the thing that we really want to emphasize here is that you don't need to, because when you break down the skills that are needed to make Neuralink work, it's actually many of the same skills that are required to make a smartwatch or modern phone work. So it's sort of, software, batteries, radios, inductive charging, and as well as things that are specific to us, like animal care and clinical and regulatory matters. Obviously, machine learning, that phrase is used a lot. But we also need to interpret the signals from the brain, which is a biological neural net. And the best thing to interpret a biological neural net is a digital neural net.
With confidence, Musk asserts that Neuralink holds the transformative power to empower tetraplegic individuals to manipulate technology more efficiently than those with fully functioning limbs.
You have to go through the FDA approvals. Like, we're not trying to sidestep any, regulatory approvals. We're doing everything, by the book and with maximum. We're going far beyond what the requirements are of the FDA from a safety standpoint. And the initial devices will really just be pretty basic. It'll be about restoring functionality to people who've lost their connection between their brain and their body. So you can imagine, like, if, say, Stephen Hawking could talk or communicate as fast as somebody with a fully functioning body. That would be amazing. So that's like what we're trying to do. That's our first application, is to restore functionality to quadriplegics, tetraplegics, and people who have just, for whatever reason, no longer have a connection between, or a limited connection between their brain and their body. And then the second application would be restoration of eyesight. So if somebody's gone completely blind, maybe even has lost the optic nerve, you can actually still directly stimulate the neurons in the visual part of the cortex. So you can give people direct vision to the brain. In fact, you could actually, depending upon what cameras you use, you could actually see in different wavelengths.
Okay.
Jordi LaPorte from, you could have that, I actually watched an episode of Star Trek Next Generation with special effects compared to what we're used to, not that great, but he's got the wraparound, glasses, and he can see in different wavelengths. So you can see ultraviolet, infrared, and that kind of thing. So you can actually do that. You could say you could see in radar if you want.
In a crescendo of promise, Elon Musk paints a compelling picture of Neuralink's potential, where the fusion of technology and neurobiology not only heals but enhances human capability beyond current comprehension.
Along the way, Neuralink can solve a lot of brain issues. Like if you got, so if you got a severed spine or something. So one of the first application we're looking to solve is implanting Neuralink in someone who is a quadriplegic or tetraplegic. So like they can't move their arms and legs, or maybe not even really move most of their face. They can like maybe blink or something like that, like Stephen Hawking, or they didn't have severed spine, but like there are various mechanical and other like mechanical breakages or diseases that break the link between your brain and body. And Neuralink can solve that. It can certainly, we're confident Neuralink can enable someone who is a tetraplegic to operate a phone or a computer faster than someone who has hands, working hands.